Hello and welcome to another tutorial. So this time around we are going to be adding a bit more to our SimStyle AI. In particular, what we're going to be doing is giving them an actual proper character mesh, and in particular looking at how we can have that character actually look around, so have them look at particular things in the world. So let's dive right on in. So the first thing I'm going to do, and I'll actually put a link to this in the description, is I'm going to import a package I've put together that has a humanoid mesh that I've already done the setup on. Now, if you're wanting to look and see how I went about setting up this humanoid mesh, that was done as part of the character controller when I set up third-person support. So I'm going to import this in. So this is just the character. It has the mesh, the anim controller, and the actual animations. So we've brought those in. So then what I want to do is my AI prefab. I am going to update this, and what I'm going to do is our character mesh here. I'm going to drag this in as a child of that simple AI one. I'm going to rename that to mesh. I'm going to, just because I don't want to get rid of the old mesh to start off with, I'm going to move the pieces of that away and turn it off. Now my mesh here, I need to link up the anim controller, which I've already set up. That was part of that package I imported. And because of how I am playing the animations, I want to actually turn off root motion. So that we now have, our characters actually have that mesh there. Now if I run this, they won't actually be playing any of the appropriate animations yet. So that's something that we need to fix. So what we need to do for that is we need to actually have it that we're communicating and conveying the particular changes or the inputs that the animation requires. So the two ones that we generally provide to that are the speed in terms of our forward speed and the speed in terms of our sideways speed. So those are the two bits that we need to actually pass through to that. So what I'm going to do is in the script, I'm going to go to base navigation 1, and I'm going to have it that we can set up here some animation options, and the main one being protected animator, and this is our anim controller. And what I will do down when we have all of our tick logic is if we have an anim controller. So if that's not equal to null, I want to have a tick animation that we run. And we'll just set up a protected abstract void tick animation. This way we can override it and do custom stuff in any of the child classes that we might want. So the Unity Nav Mesh one, we need to set up that tick now. So we have our public override void, and actually it can be a protected override void. And this would be tick animation. So what I want to do in this, as I said, I need to pass through the forward speed and the sideways speed. That's how the animation system that we've set up blends between the particular animations to play. So I need to be able to calculate my forward speed. So what I can do is the forward speed is going to be, and this is where we use the dot product, a vector3 dot of our linked agent velocity, so not the desired velocity, but the actual velocity that we are moving at, and our transform forward, and then we divide that by the linked agent speed, because that's the maximum speed. Because these forwards and sideways speeds that we're calculating, they should be in the -1 to 1 range. So a 1 on the forward speed would mean that we are running perfectly forward, and we are doing that at the maximum speed that we can, whereas a -1 would mean that we were running backwards. So we do a similar process for sideways speed, and that's going to again be the vector3 dot with the velocity. This time we use, not that, we use transform dot right and divide by that speed. Then all we need to do with this, because we've set up most of the logic in the anim controller, is we do a set float of forward speed to the forward speed we've calculated, and exactly the same thing, but with sideways speed, like that. So that looks good. So I'm going to just make sure, cool, sometimes when it auto-completes, it does add in extra usings that you don't actually want, which is how you can sometimes end up with some really obscure usings included. But that should be good. That should mean it's able to pass that info through. So if I just go and update the prefab so that it is linking to the correct animator, like that, then what I should find is that these ones actually play their animations. Now you can see they're floating a little bit off the ground. So we might find that what we're actually needing is a tiny bit of an offset. So the way I'd figure that out, and this is not unusual to run into something like this, what I would do is I would pick one of the characters and I would go to their mesh and just see, okay, where do we need to offset that to? So it's probably something quite small, -0.09 looks about right. So we can test. So this is very not unusual to run into stuff like this. So that looks pretty good. So that's great. We've got a humanoid mesh in there. Now what we want to do is we want to get these AIs able to actually look at something. So initially, I'm going to take this one here, and I'm going to actually turn off its behaviors so it's just standing still, because what I'm going to set up is a script here that's going to be look at point of interest, and I'm going to add this onto the prefab. So this is going to control how that AI looks. Now, because we're following the standard structure for our rig, it's referred to, so the actual rig for the skeleton here, we have an actual very specific bone that we can go and refer to. So what we're looking for is this head bone. Because what we'll find is this head bone, if I adjust the yaw angle, you can see, head rotates side to side. If I adjust the pitch, then it pitches up and down. Not that we're going to need it, but if we wanted to, we could also make it rotate from side to side. So, okay, The transform of this, we can modify that while it's actually running. So we're modifying the transform of the head bone. So we can change that while it's actually running, and that will allow us to have it look at things. Now, when we're having a look at things, there's a couple of considerations there. There are things we will run into where if we have no constraints on where it can look at, then it can kind of go exorcist style and the head can be rotated looking behind you and potentially, could be behind you and like straight up. It can go really badly. We want to avoid that. So there will be some limits that we put in. We won't put those limits in initially, but we will be able to add those in. But the key thing is it's this head bone that we're wanting to control. Now, the other important thing is the head bone's located here, but the eyes are actually located further up. And while it may seem like the distance is quite small, and it works out with this model to be about 12 to 15 centimeters, so not a huge distance. You can actually tell if you don't account for that it's looking at slightly the wrong location. It's kind of one of the things about how our brains work that we are quite good at being able to tell what something particular another human is looking at. So if it's off, it's really noticeable. In doing the prep for this, I spent quite a while tweaking things to get it so that it was actually lining up perfectly. And I'll show you some debug tools for how we can test that. Because having it lining up perfectly and looking correct is really noticeable when you get it wrong. So we want to make sure we get it right. So, okay, I'm going to need some kind of offsetting for the eyes, and I'm going to need a reference to this head bone. So what I'm going to set up in my look at point of interest script is a couple of things. Firstly, I'm going to have a transform here for the head bone. I'm going to also have a vector 3 for the eye offset. I might actually refer to that as the head bone to eye offset. So this is the eye configuration. Maybe the head configuration is probably a better term. And then we need to control our looking at. So we want to have a limit on how fast it can rotate. Again, we don't want something that just snaps at an unnatural speed. So we're going to have a serialized field, and this will be our look at speed. I don't think we need to have a separate one for pitch and yaw. I think they can be the same speed. We could easily split it out if we wanted to. That's not a difficult change to make, but I think we really can just not have two separate ones. Actually, I might make it 90 to begin with. It's one of the things with these values, 90 seems fast, but it's actually ends up when we look at it, it looks a little bit on the slow side because we can rotate our heads pretty fast. Okay, that's good. Now we need to clamp how far to the side we can look. So we're going to have a serialized field for our max yaw angle. And probably around 70, 75, I think is good here. And then pitch is an interesting one. So yaw, we're looking at clamping it between minus and plus 75. Pitch, and yaw, it makes sense for it to be the same. Pitch, we actually want to allow two different ones because tilting down versus tilting back, it's kind of a bit of a different range that we might have there. And again, this is something where you might end up changing the yaw angle to be split, so it has a min and a max one, because maybe there's something about the character's left side that limits how far they turn. So again, you could split that out if you wanted to. So for the min pitch angle, I'm going to say -30. And I will also keep track of the max pitch angle. And we'll make that 45. Then, okay, well, I need my current look target. Also going to keep track of the previous look target. Going to put in some debug options. So we will have debug, and what this will be, so I'll have one draw look direction, which I'm going to turn on by default. We'll then also have a transform. This will be a debug look target to set, and then a boolean to control applying that. Update look target, which we will have set to false to begin with. So that looks pretty good. We'll see how we go with getting this stuff set up. So we'll get this bin and update going first for working with the look target. So if debug update look target is set, then I want to actually create my function for setting the look target, just so I've got it all ready to go. And all that will do, let's do that. This is just going to set that look target to set, and it will also turn off that boolean. That's good. Just a little bit of, boilerplate stuff there to get us up and running. Now, we're going to be rotating the head bone. And initially, what I'm going to do is I'm just going to do a super basic thing to check that the debug drawer is working. The super basic one just uses the transform lookouts, but it then has no rate limitations. It has no angle limitations, anything like that. So I just will use that to test that essentially the debug is working. So with applying these changes to the head bone stuff, there's a few issues you can easily run into, and they come down to the order that things happen in Unity. So if you are wanting to apply a modification to a bone on a character that is already being animated, so a character where that bone is already getting some rotation or transformations otherwise applied to it, you need to do it in late update. Otherwise, everything you do is going to get stomped. So that's an important thing to remember. Anytime you're doing stuff where you are modifying how a character is currently posed, do that in late update, not in update or fixed update. So we are going to have a late update here. So, okay. In terms of what it needs to do, firstly, I'm going to set up the debug drawing. So if debug draw look direction is on, then what I need to do for this is, well, firstly, I need to get where our eyes are currently located. So vector 3 world space eye position. And what this is if I take my head bone transform, I can transform a point, which is in local space. So transform, point, direction, those go from a local space value to world space. There is also an inverse transform point, which will go from world to local space. So I've transformed that eye offset. So now I have where the character's eyes are in world space. And all I'm going to do is do a debug draw line from that eye position to that eye position plus our head bone transform dot forward, and we'll extend this out maybe 10 meters, and we'll just draw that in red. So that's cool. We've got the look direction. Then I'm going to check, okay, if we have a look target. So I'm going to just initially implement the version that is not going to compensate for the eye offset, and that is also not going to give us any rate limits. I just want to test if the bare bones stuff is functional. So what I would do is I could say head bone transform, look at, current look at target. So let's test this out. There's going to be a couple of things we need to link up. So we need to link up the head bone transform. So bring over the head bone. Now I know with this that the eye position, the offset, as I said, is about that halfway between sort of 10 to 15 centimeters. So I know that. So that's good. Now, this one here, I am going to give them a look target. So I'm just going to create a sphere in the world. I'm going to bring that over here. And that is going to be the look target. And I'm just going to turn on the debug update look target. So the first time it runs, it will go and grab that. So what I'm hoping to see is that it's looking pretty much at the sphere, which it is. And then, okay, as I move the sphere up, that's looking pretty good. And it's a little hard to tell, but it's not looking dead at the center of the sphere. There is that offset, and that's because of the eye position. Now, as I said, this is going to allow us to do things like of this, which would be very painful, and we want to try and avoid doing stuff like of that. But we've tested that the debug drawing works. We've tested that the general sort of stuff, we're updating the right bone. We know we're in a good spot with those parts of it. So that's good. So what we can start doing now is starting to enforce those limits that we have. Starting to also enforce, those speed limitations as well. So both the actual angle limits and the speed limit. So what I'm going to do is I am going to keep track of my desired yaw delta will be 0 to start, and the desired pitch will be the same. I'm also going to have my current yaw delta and current pitch delta. So that's good. So now in late update, it's where we want to start calculating these. We want to start doing smoothing of the rotations. So one thing I'm going to do is, if we don't have a current look target, but if our previous look target was valid, and we get rid of those extra ones, we say that our desired pitch is our desired yaw, which is 0. So return to looking forwards. And we just make sure that we're always updating that previous target. So that's good. So, okay, we want to do the calculations for these. So, first thing I need to do is I need to calculate where I am trying to look at in local space. So, like I said, with the transform point, there is an inverse transform point. So if I do head bone transform, inverse transform point, and I can give that our current look target position, so that will give me a vector in local space that is looking at that point. So this is our local space look direction. Now that is not going to take into account the eye offset, because that is a location that is essentially looking from, I guess, yeah, on myself, it would be basically sort of, here at the base of the skull, like where our head pivots. That's where it's going to be looking from. It's not from the eye location. So what I do is I subtract my head bone to eye offset. So that'll give me a direction that is correctly compensated for that. So now this direction, that has horizontal components, our yaw for turning. It also has our vertical components, our pitch for tilting. So I need to decompose this into those components. So what I'm going to do is, there's a couple of ways I could go about this. I could do a projection onto planes, things like that. But because I've already brought everything into local space, I can actually work with it fully in local space. So first thing I want to do is I want to calculate that yaw change that I would be looking for. So this is going to be the yaw delta. And what I would do for that is this is where I would use ATAN2, because I want it to properly be correct for all possible quadrants. And I want to accurately resolve all quadrants of where it could be. And then I can use my local space direction, in this case .x, and local space direction .z. So I have that. Now that gives me back something in radians, and I actually need it in degrees. So I'm going to convert that. For our pitch delta, what I would do is a mathf. Now in this case, we actually don't need to resolve it in all coordinates because we're only looking up and down. We're not trying to rotate to behind us. So what I would do is I would just use an ATAN, and it would be Ry divided by Rz, and again, we convert that 2 degrees. So that's great. I've got my pitch and yaw values that I need to calculate. First thing I want to do is I want to check if either of those is outside of our limits. Because if either of them is outside of our limits, we don't try and look at the target. So if a mathf and the absolute value of the yaw delta, if that is less than or equal to our max yaw delta, or max yaw angle, and our pitch delta is greater than or equal to our min pitch angle, and our pitch delta is less than or equal to our max, then we can actually do our calculations. Otherwise, we do again that reset for looking forwards. So we only want to apply our rotations if it's actually going to be valid to do so. We get rid of that look at because we're going to be calculating all of this manually. So, okay, that looks pretty good. So what we would say is our desired yaw delta is yaw delta, and our desired pitch delta is that. So if the target is within look limits, then set Well, then try to look at it. Well, actually, no, it is set it as the desired pitch and yaw. So that's good. We've got this calculating those values. Now we haven't done any clamping of speed, anything like of that. We haven't done any actual application of these yet, and that's also okay. So what we're going to do is, firstly, for applying them. So we're going to not apply the speed limit initially. Again, this just allows us to test this bit by bit. So the way we actually do this, and this may seem odd, is we take our head bones transform, and we're going to actually modify the rotation of that. So I'm going to take the local rotation, and I'm going to multiply that by a quaternion, and we use the Euler function. So first thing we do is we give it the pitch, and we actually need to invert that, just because of how the maths works out. Then we give it the yaw. Like that. Now, what I will do is, while this is wrong, I will actually have this use the desired ones for now. Oops, desired yaw delta. And the reason it's wrong is because the current is what we want to actually be lerping. So we do want to use current here, but I'm going to use desired for now so that we can just test, does this work the way that we want it to? So let's run this up. So we can see it's looking dead center at it. So that's good. Still tilting correctly. Now, if I bring this around, what I want to hopefully see is there's a point where it snaps back, which we saw. So that's good. It's going instantaneously, and it has those limits. So that's good. Now we can actually factor in the speed. So I'll put these back to current. And then what I will do is, if, and we're checking if something is not approximately. So if our current yaw is not approximately the desired yaw delta, or when we do the same check but with pitch. So what we're essentially checking here is, are we not close to the desired values? If either of these is off, then what we will do is we will move towards that. So I would say, oops, that should be current pitch delta. So I would say current pitch delta is a math F. We use move towards angle. Just move towards should be fine in this case, but just to be safe. So we want to move our current pitch delta towards the desired pitch delta, and its look at speed by time dot delta time. That's how far we're allowing it to move in this particular time interval. The current yaw follows the exact same process. So move towards angle, current yaw delta, desired yaw delta, and again, look at speed by time dot delta time. This should give us something that is going to slowly turn towards the target that we want it to. So you can see, slow look around. This is what I mean with 90 degrees seems like that would actually feel fast, but it actually feels pretty slow. But that's good. The character can happily look around, which is perfect. That's what we were wanting. So I'm going to get rid of that sphere now, and I'm going to get rid of that look target to set, what I'll do is, that's not resetting properly. There we go. We'll turn off the debug update look target. So again, that one actually, we can just do a revert. So that's good. We'll turn that AI back on. And what I'm going to do is I'm now going to make it so that when we start moving towards something, so essentially when we have picked our target to head towards, I want to go and start looking at that. That's the goal of what we're trying to achieve with this. So let's get that set up. That's actually going to be a modification to our not so simple AI script. So there's a few ways we could go about approaching this. One option is what we could do is provide an event when we've selected to look at something. Looks like that's accidentally included visual scripting, so we'll remove that. So we could fire off an event when we have selected to look at a particular thing. That's absolutely an option. There's a lot of different ways of how we could go about approaching this. There's no necessarily right or wrong way. I think for this, what I might do is using Unity Engine events. So I might actually do this as an event. When I was initially setting this up and testing it, I didn't do it as an event, but I actually kind of like the idea of using an event for it. So Unity event provides a transform, and this will be on new object picked, object selected. Might be a good name for it. So where that happens is down here where we're trying to pick the best interaction. So in pick best interaction, so effort found none, we would invoke that with null being provided. If we have selected one, then we would invoke that with current interaction transform. That should be good. That means we have to do a little bit of updating to the prefab, which is okay. And what I would have to set up here is this on new object selected. I could drag in point of interest script, and we add in set look target. So that should mean both of these AIs have that, which they do. So what we should now find is when they pick something to go towards, they actually look at that. So you can see it's headed over here. Now, doesn't look like it's quite looking at the right location. So if we select our simple ones, you can see what we want to do is actually check, because it did seem to briefly look at the right thing. But then, so this one here, it's looking at it. So that one stayed looking at it correctly. It could be that this one doesn't have the more sophisticated logic in it for making the character's face, and it was on a fair bit of an angle, so it's probably actually just outside of its angle range. But something I could do is on those interactables, because at the moment where it looks is kind of not great, what I could give this is I could actually give this, so the interaction marker, if we check where those are in these, and so this has the interaction point. Those are on the ground. So what I want to add in here is a field, and this will be a transform for the look at point. Now this is using the slightly older style of how I set things up. So we will stick with that for now, just because I don't want to go and change half of the code over and half of it not. So this would have a lookout point, and that maps to that. This just allows us to control, because interaction marker is where they stand. The lookout point is where we want them to be facing. So that looks good. What I would say is I could actually do something a little bit trickier here of if look at point is not equal to null, then we do that. Otherwise, we give back just our actual transform rather than anything like the interaction marker transform. So this way it'll always return something, which is good. So what I would change here is this would end up being, I would say, so that's the, and I assume selected object is a smart object, so that's good. So we'd say selected object, look at point, and then I can set up here an actual custom look at point for any of these. Now it's probably actually going to be pretty good where it's currently got, but look at point. So that, probably want to have that about halfway up. Might add in a little sphere to that just to actually nicely position it. So might say that they tend to look at the upper shelf. So that's good. We could configure that for our other ones if we wanted, but for now we will just keep it configured for that bookshelf, which I will link up that look at point now. Oh, fix selected. Yep, there we go. So look at points connected up. That should be good. We might also set it up for the TV as well. So we'll have a look at point. Click that up. Just do the same thing with creating a sphere just so we can position it. Less of an issue with things like the microwave, but with stuff like of the TV and the bookshelf that are quite large objects, definitely will make a noticeable difference. So that's good. So let's test that out. That should mean a little bit better positioning with where they're looking. So you can see that one's not quite looking at where we'd expect. Heads over to the TV. Also still not quite looking at where we would expect. So we just want to go and test and see. What I'll do is for the look at one here, I'm actually going to temporarily serialize field. I'll just straight away make that public. Just want to test where it's actually going and looking at. So we'll run this and we'll see what they end up setting down here as their current look target. We just want to make sure that it gets set to something. So this one's headed to the TV. So it's looking at look at point. So we can see that actual look at point for the TV is in the wrong spot. Look at point. Yeah. Looks like we have that. We moved We accidentally moved the TV rather than the look at point. Oh, I know what it'll be. I moved the sphere, not the actual point. So we just want to check our bookshelf. Easy to have happen. Cool, I did adjust that. Let's just check where that sphere is though. Okay, yep, so I've done the same thing. It's so easy to have happen. Go. Now we should find Wanda's over here, and now realizing the scale of the TV relative to the person is quite large. But when they're there, they are looking at the look at point we have given them. Could even have multiple ones there, so if multiple AIs are looking at it. Now this one, it's hit the angle limits. So we could give them a slightly larger one if we wanted, but that's likely to result in them, having their head twisting weirdly. The better fix would actually be to bring across the changes that are done in the character controller to allow it to properly turn and rotate when it reaches the destination. So I will bring those across at a later point. But for now, we have our AIs have a skeleton, and we've seen how we can have them look at particular things in the world, how we can control the angle range they're able to tilt their head, and also the speed at which they're able to change that. So that's really good. We've got these up and running. It's looking great. So dive on in and experiment with this. If you are bringing in your own character meshes, as long as they're following the conventions there with the humanoid meshes for Unity, as long as they're following that, you should be able to pretty much just link up the correct head bone and everything works. That's why there is that consistency. That's really important with sort of setting up the humanoid animations. Makes life so much easier. But dive in and experiment with it. See what you can create. And see what other things you might want to set up with the headbone looking at stuff. If you wanted, you could have an exorcist mode. This would allow you to do that, of making the character's head spin. But only if you're wanting for that particular effect. Generally, we don't want that. But experiment with it and see what you can do. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you've got any questions, chuck those in a comment below. If you were looking for the code for the project, then I do have that available up on GitHub. There is a link to that in the description, and you can use that code in any of your own projects, commercial and non-commercial ones. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description as well. But until next time, bye.